Two and a Half Admins, episode 190. I'm Joe.
I'm Jim.
And I'm Alan.
And here we are again. Before we get started, just a quick plug for Hybrid Cloud Show at hybridcloudshow.com. This is a new podcast to the Late Night Linux family, and it features 4 industry professionals talking about public cloud, private cloud, and everything in between. So check it out, hybridcloudshow.com. There was a backdoor in XZ Utils. Now, we covered this on Late Night Linux in depth, but it's a big enough story that I want to hear your two's take on this. So have at it.
Well, first off, the big thing that I want to point out is that it's been big meme for at least a decade to say that, it's bullshit that a million eyes make open source code bugs shallower. But, here we have one of the million eyes who was, packaging Postgres and noticed something was slightly off, and it led him to an SSH server compromise by way of an archive utility that's linked in through systemd somewhere else. So I don't see that guy having found that issue if he didn't have access to the source code.
Yeah, for sure. And while that saying is mostly true, obviously the problem is those eyeballs have to be on the source code in order for it to find anything. But to Jim's point, the ability to go there when it's necessary is how these things get found. So yeah, a Postgres developer who happens to work at Microsoft was doing some benchmarking, and being like any people that do benchmarking like Jim, he was like, wait a minute, this part of the benchmark that is just setting up and not actually doing the benchmark is suddenly taking longer. Why is it taking longer to SSH into the machine? That shouldn't have changed from last time I ran these benchmarks. And then while digging into it, it's like SSH is using a lot more CPU and all this other stuff is happening. And eventually figured out, hey, there's some fishy stuff going on here, and posted it to the distro mailing list, and people dug into it and figured out what was going on.
I don't know that developer. I haven't spoken to that developer, but as somebody who got owned once by way of a Trojan SSH daemon, that smells a lot to me like somebody who has shared my pain at some point in the past. Because if that's ever happened to you, if you've ever gotten owned with a Trojan SSH daemon, odds are really good it didn't work quite right. The one that I got owned with didn't work quite right, and I actually filed bugs with Debian because I had been rolled up so severely. My SSH had been Trojaned in basically every machine I had access to. I thought that it was an actual legit software upgrade that had broken SCP on my machines, and I opened a bug. And ever since then, yeah, anything that looks slightly off about SSHing or SCPing or anything, I start digging into it pretty freaking hard.
Yeah, in this case, I think it's more as a person who's crazy about performance. They're like, hey, why is something suddenly not performing like it used to? Why did this suddenly get much worse? And digging into why. And so it turns out that the developer of the XZ packages has been doing it for a long time. And, XZ isn't something that really changes that much anymore. So it's mostly been kind of maintenance mode. And the guy was having his own health issues and in general was looking for some help from the community. And nobody was really stepping up because it's not really a sexy project, right? It's a file compressor that hasn't changed in a long time. But suddenly somebody showed up and was like, yeah, I can help. And so they're like, sure, get them helping. And then it turns out they started slipping things in, but doing it pretty cleverly. They added some binary test files to the test suite for XZ that looked like they were random data. It's like, yeah, this one will manage to crash XZ or whatever.
You're bypassing an important facet here, Alan, which is that this same person who showed up and began helping also began pushing a lot more code than the project had been seeing for some time and started telling the original maintainer, you're a bottleneck and you're keeping progress from happening.
Yeah, but not directly via sock puppet accounts.
That too. And then, I was getting to, also, once they had newer releases, going and using those sock puppets to nag distros like Fedora to hurry up and pull in this newer version without realizing that it was full of a Trojan. But yeah, so in the files they checked in as part of the test suite, it turns out they buried some code in basically the configure script that would replace some of the bits in those test files and basically decrypt the Trojan that was built in there and make it start doing more than it was supposed to do. Interestingly, as part of that, they were checking for a bunch of things to try to make sure this wouldn't try to deploy on machines where it wouldn't work. So it only ever did this if you were using GCC. If you were on a Linux distro that used Clang, it wouldn't work. And then it only would try to do it on x86 64. So if you were on an ARM machine, it wouldn't try to do it. and a whole bunch of tests like this. And it was very specifically being like, only if it's Linux, only if it's GCC, only if it's AMD 64, and so on, to try to make sure that it wouldn't just crash or segfault or make other things that would make people obviously look into why is this doing this and end up finding the Trojan.
In my personal opinion, this absolutely reeks of nation-state actor because of the careful targeting that you mentioned. Commercial malware operatives, in my experience, they're not usually trying to limit how many machines can get infected with their crap. They don't care. As long as their targets get infected, they're fine with it. So the exclusions are just an extra step they don't really want to bother with. Once you get to the nation-state level, they start getting a lot more concerned about very long install times before the detection happens, your vulnerability window when you're compromised. And so they get a lot more careful about that. They're a lot more willing to spend time, effort, and resources on getting it dialed in. I don't see any other way this is anything but a nation-state actor. When you look at the length of time that, not just how long it took to get the code in, but like clearly to me, this all was going to plan. The plan was to spend years getting this code in. And then the actual, the mechanism is so multifaceted with the like, okay, we're not just going to go for SSH and Trojan SSH. No. We're not just going to go for systemd and Trojan systemd. No. We're going to go for, let's say, XZ, an old archive utility nobody ever even really thinks about anymore, but it's on everybody's system. And thanks to systemd, we can work out a way to get that linked in a way that, because SSH touches systemd and XZ touches systemd, that under these very specific sets of circumstances, we can activate the thing. Now, all this makes it way harder to detect, but the thing is, if you're a commercial malware vendor, you don't need it to be that difficult to detect.
Yeah, the Trojan is in libLZMA, which is a library version of XZ, and that's why it's in the XZ Utils package, not the actual XZ package itself, because it's only the library that's even an optional component. But that is built into systemd. I don't know exactly why, but I imagine it's for like doing the log compression or something, or even just for journalctl to be able to read compressed logs. And because of the way it works with overlinking, it means that because SSHD links into the systemd library, and so does this, that suddenly you got LZMA in your SSH, even though SSH Portable from the OpenBSD project does not use XZ at all. It's why the BSDs weren't affected by this. Even FreeBSD happens to include the vulnerable version of XZ in its latest main branch, but because FreeBSD always uses its own build system and doesn't run the configure script that come from the package, it never had a chance to try the exploit, on top of the fact that we use Clang and wouldn't match the Linux x86-64. So the Trojan would have avoided running anyway because it wouldn't have worked on FreeBSD and somebody would have noticed and found them out.
It couldn't have worked on FreeBSD anyway because you're not a systemd distro, so there's no way to tie XZ to SSH. Like, under FreeBSD, how the hell would you touch XZ remotely?
Yeah, some other daemon that maybe uses libLZMA, but I can't think of one that does. Honestly, for most of those daemons, it'd almost make more sense to go after LZ4, because that's built into like MySQL and I think some web servers and like Memcached and lots of other things that might actually be listening on a port. Although it has a maintainer who's active and paid by Meta to maintain it.
Sounds like it wouldn't be the worst thing in the world for somebody, I don't know who, to sit down and think up a list of like, gee, if I were a nation state with a black hat on my head, what very underthought about but widely utilized pieces of open source infrastructure would I attack? This already feels to me like somebody saw that XKCD cartoon, the one with the toothpick holding up like tons of wood. Mm-hmm. And, it says like, the one developer that's maintaining, the 30-year-old project that nobody thinks about. Like somebody saw that cartoon and was like, oh, yeah, I can work with that.
I saw a version of that somebody did on Twitter after this came out that shows it's like the whole pile is held up by a string of those that are wobbling.
Yeah.
Because it's not just one library, right? Like we've seen exactly this. OpenSSL with Heartbleed and so on, and then, Log4j and all these other ones, and then now the libLZMA. Because, like to Jim's point, I think the first thing I'd do is what other library is, because of systemd, surprisingly linked into OpenSSH? Because I'm guessing LZMA isn't the only one.
No, it certainly wouldn't be because, I mean, again, it's not a direct SSH tie anyway.
Exactly.
It's via systemd. It's, as far as I can tell, it's damn near anything that touches systemd. I think you're correct. I think the reason LZMA is linked from systemd is because of journal control. And if things that are linked to journal control can get touched from SSH, then, well, we're right back to reasons why, although I am not one of those zealots. It's like, everything about systemd is evil and horrible and I hate it and blah, blah, blah. Like, I'm really not a fan. Like, I get that it brought some desperately desirable things into the fold, but I like the Unix philosophy and systemd is not the Unix philosophy.
OpenZFS merges support for using multiple task queues to increase performance, says the headline in Phoronix. What it should have said was to increase performance for ZVols.
Yeah, so this is a commit that came from IX Systems as part of Tailscale. So years ago, Delphix committed support for basically deferring the work in a ZVol to a separate task queue. And specifically, that meant if you had a single-threaded workload, by taking the work and dispatching it to a task queue, it meant you could actually get some concurrency where you wouldn't have got it before. And so for certain workloads, that made ZVols a bit faster under Linux. What IX found is that because there was only one task queue that could do, I think, 32 bits of work, that when the system was busy, and especially if you had a lot of ZVols with a lot of VMs, it wouldn't use all the CPUs and make enough work for itself. So with this change, they now can have multiple different task queues and spread the work across them so that multiple CPUs will be involved in executing these IOs. And so with that change, looking at using FIO with 16 jobs, with the change, they found that as they got further and further in the file, they will get higher performance. And so this change where before ZFS would top out around 25 gigabytes a second, reading from a pool of NVMEs. And then also with the old version, as you added more and more work, because the queue was a single CPU, it would actually, you could see the performance drop down to like 18 gigabytes a second. With the change, it can reach almost 40 gigabytes a second by using more than one CPU.
Sounds like it might be time to revisit my notorious benchmarking ZVols versus datasets for VM hosting.
Yeah, because I think that's very specifically what this change was targeted at. It looks like it does it specifically to decide which task queue to dispatch it to. It does it based on a range of size. So like if you're reading 100 megabytes into the ZVol, there's like the first 128 megabytes go to this task queue and the next to another and another, so that requests that are close together can still be aggregated nicely and get the cache advantages of running off the same CPU. But when you're reading a bunch of different places by, doing random reads, that it's going to light up all the CPUs that way.
I know this is aimed at much bigger iron and higher queue depth than I normally work with, but honestly, I'm still feeling pretty positive about this maybe making a big impact in how well ZVols actually perform in the real world, because it reminds me when we talk about, the increased queue depth, when we talk about being able to use multiple task queues, it reminds me of my surprise when I discovered that the emulated NVMe storage under Beehive was significantly faster even on a SATA SSD than, VirtIO drivers were under KVM. And there again, a lot of the reason was, for those of you who aren't aware, SATA has a maximum queue depth of 32, whereas NVMe has a maximum queue depth of, if I recall correctly, 65,535.
Well, that's the protocol's maximum. Most devices only implement up to about 64, but they usually implement 63 queues, each of 64, versus one queue of 32.
Yeah. So, we're still talking about not just the difference between 32 and 64. We're talking about the difference between, 64 squared and 32.
Yeah.
So it's a lot.
Especially like in this benchmark that IX was using NVMe drives. In order to get the performance out of those, you need to put work in all those queues. And if you only have a single task queue with a depth of 32, you're not going to be able to keep the NVMe busy and get all the performance it has to offer.
And I will say, NVMe storage has been one of the most difficult things to tune OpenZFS to get the maximum performance out of. I mostly work more in the the SATA and SAS space. And I generally find that it's not hard at all to tune OpenZFS to outperform conventional file systems for most workloads, on that hardware. But once you go NVMe, things start getting a lot more difficult in much the same way they get more difficult on the network side when you go from 1 gigabit where, the network's always the bottleneck to 10 plus gigabits where the network's usually not the bottleneck and you got to dot all your I's and cross all your T's and suddenly everything matters.
Yeah, especially NVMe's got latency that's in sometimes tens or less microseconds per I/O, whereas, your hard drive is at 4 milliseconds. So that's a very big difference between 4 milliseconds and like 4 microseconds. That's literally 1,000 times less latency. And so part of that is ZFS by default was always trying to be like, oh, I see you're trying to do a bunch of I/O. I'm going to try to sort it and coalesce it and give it to the hard drive in a way that will allow the hard drive to do the most with it. With NVMe, you're like, ZFS, you need to get out of the way and just give all the work to the drive. It's going to finish it faster than you can feed it. And so every bit of CPU time you try to spend optimizing it is taking longer than the drive would have just finished if we just give it the work.
That's about the only explanation I can come up with for the emulated NVMe being so much faster, even on SATA hardware, that only has actually, 132 deep task queue. And yet, by having the virtual NVMe style, 64 by 64, the actual throughput was much higher. And if I recall correctly, the latency was a bit lower as well.
Yeah, it was basically getting the stuff down to the host faster so that it could get it to the drive faster. And again, not being bottlenecked by just a single queue.
Okay, this episode is sponsored by Tailscale. Go to tailscale.com/25A. Tailscale is an easy-to-deploy, zero-config, no-fuss VPN that allows you to build simple networks across complex infrastructure. It's super simple to set up, and you can have machines and devices all over the world connected to each other as if they were on the same LAN in minutes. Tailscale is WireGuard on easy mode, and that's why loads of late-night Linux family hosts are Tailscale users. Amalith from Linux DevTime uses Tailscale for his 3D printers, all his servers, and his home automation. And Gary from Linux After Dark and I both send our offsite backups to our parents' houses using Tailscale. So support the show and check out Tailscale for yourself. Go to tailscale.com/25A and try Tailscale out for free for up to 100 devices and 3 users with no credit card required. That's tailscale.com/25A. X fixes URL blunder that could enable social media phishing.
You mean Twitter?
No, I mean X.
Look, I don't dead name people, but the company that Elon Musk bought is not a person, and it's still Twitter.
Yeah. This is funny because it was just a couple of weeks ago, I remember Jim was saying that the support emails and stuff that come from X still say Twitter on them. And like if you go into support, it still says Twitter everywhere. And we were kind of teasing them for not having finished the switchover. In an attempt to do that more, they decided that what they would do is in all the URLs they display, if people are linking to tweets and so on as twitter.com/blah, blah, blah, we're going to replace all those to actually be x.com. And so they basically changed the code. So it would do a search replace on the URLs and replace any instance of twitter.com with x.com. The problem being they didn't put bounds on their search replace. So somebody found that if they registered the website URL netflixtwitter.com, replacing the X in Netflix with the word Twitter.
Netflix Twitter.
Yeah, Netflix Twitter. When they linked to that on Twitter, you would look at it and it would say it's a link to netflix.com, but when you clicked at it, you would actually get taken to Netflix Twitter and get a malicious site, or in this case, a site saying, I bought this domain to stop people doing this.
Which appears to be some random Chinese dude that was just like, nah, this could be a problem eventually, and I'm just not having it. Here's my $10, solve this.
Yeah. Because I think the other one they did was Roblox, the kids' video game.
Mm-hmm.
It very much kind of reminded me of the one with, PayPal spelled with the Russian A and other stuff with the puny code that we've talked about months and months and months ago.
What it reminded me of was back in 2021 when Russia's Roskomnadzor, internet filtering and snooping group, decided that pre-Elon Musk's Twitter takeover, Putin's Russia was not a fan of Twitter, where all the dirty liberals were, talking about how horrible autocrats are. And he didn't want the Russian people seeing it. So Roskomnadzor tar-pitted Twitter. Well, at least that was the intent. But unfortunately, when they tar-pitted t.co, which is the redirection link that Twitter uses when you put a link in your tweets, whatever link you put in actually gets converted into a t.co redirection link. And so Roskomnadzor essentially The first step was the entire nation, basically all the ISPs have to have this government black box right in line with the internet feed, and it filters out anything that it doesn't like, changes things, whatever. And one of the functions was it was set to tar pit any link to t.co to, it was roughly like, it was like 90 kilobits. I mean, it was bad. Problem is, again, just like today, they used an unbounded regex to identify the things that they wanted to tar pit. So anything that included t.co got tar pitted, which includes, for example, Microsoft.com. It's like a lot of regex stories, you know? You had 99 problems, you pull a regex down to solve them, you got 99 million problems.
Let's do some free consulting then. But first, just a quick thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. If you want to join those people, you can go to 2.5admins.com/support. And remember that for various amounts on Patreon, you can get an advert-free RSS feed with either just this show or all the shows in the Late Night Linux family. And you even get some episodes early. And if you want to send any questions for Jim and Alan or your feedback, you can email show@2.5admins.com. Another perk of being a patron is you get to skip the queue, which is what Brandon has done. He writes, I have a question about setting up a home ZFS array. I have a home PC with a mini ITX motherboard that I'm using as the home server. The NVMe disk on the motherboard is running my Pop! OS instance. I have 4 SATA hard disks installed in a RAID Z configuration. So far, everything has been great, but my motherboard only has 4 SATA connectors. My question is, what is a good method for home users to configure RAID arrays with 4 or more SATA hard disks? And then he talks about some enclosures on Amazon that support RAID and non-RAID options and USB 3 and USB-C.
Yeah, I have a very strong personal distaste for USB-connected hard drives, especially for anything like a server or NAS. Definitely avoid all the RAID ones because you're using ZFS. But in general, I very strongly avoid anything that involves USB for persistent storage, right? USB was designed for temporary storage, not for always-on storage. And so, yeah, getting a PCIe expansion card that does SATA is probably your easiest answer. You can go all the way and get a proper HBA that supports lots of hard drives and so on. But, you know, if you just need a couple of extra drives, you know, you say it's a mini ITX motherboard, so I'm assuming it's not a case that's going to fit 12 hard drives, so you're not looking to add that many more. So I've used cheap like the StarTech or other brands where you just get 2 or 4 more SATA ports for a tiny PCIe card, and then you just slap it in there and you get a couple extra ports. And sometimes it's just, I want to have 5 hard drives instead of 4, but there's only 4 SATA ports on the motherboard.
Now I'm going to jump in here because Alan didn't go hard enough. It is not just an issue of personal distaste. Do not use one of those multiple drive USB to SATA enclosures for permanently connected storage. You will encounter problems with it. It may take you a couple of years, but it is going to happen. I say that not only because I've seen it happen to other people countless times. I say that because I've personally tried to make one of those things work even just for intermittent stuff, like not my main bread and butter, like this is where all of my data is, but just as like, okay, well, here's something I can put drives in and, you know, just kind of deal with it whenever. And yeah, they don't last very long and you have problems. USB is not good for permanently connected storage, period. So, expanding a little bit on the rest of what Alan had to say, when we talk about the cheap PCIe SATA cards, that actually is a host bus adapter. There's not like really a big magic difference between that and a quote proper unquote HBA, you know, made by LSI or whoever. They are the same thing. The cheap one is just cheap. Now, they are generally perfectly fine. It's possible to encounter the absolute cheapest SATA card you can find that is just junk. But typically, you know, even the $50 or $60 ones, they are perfectly fine. You can get 2 ports or 4 ports for about $50 or $60. It will work great. The major limitation is that those cards are not going to give you more than somewhere between 500 and about 650 megabytes per second throughput total for all drives connected to the adapter. If you are hoping to get throughput in the order of like a gigabyte or 2 per second or more, that's where you need to dip into the more expensive HBAs. You're going to be looking at spending somewhere between typically $150 and about $350, depending on what features you're looking for, to get a relatively modern LSI card. Now, even there, you don't necessarily have to spend a ton of money on like the newest thing. Any LSI card in the last decade or so is going to be enough to get you to about a gigabyte per second, maybe 1.5 gigabytes per second of throughput, assuming the drives you connect to it are capable of that. So that's kind of already enough, and you can probably get into that for just $150 for the card. The other thing that I will mention is that the hot swap bays are really, really, really nice to have. So if you're in that mode of thinking about how do I upgrade, and as a home user, how do I not break the bank but have more drives and make this, easy to work on, you have a couple of choices. Silverstone is one of the few vendors out there that makes 8-bay cases relatively inexpensive, like I think $120, $150. You get 8 hot swap bays on the front that you can connect to your host bus adapter or directly, to your motherboard if you've got enough SATA ports, and it works. Now, the bays feel plasticky and cheap, and they are plasticky and cheap, but I've got a couple of these things out in the field, and I haven't had an actual problem with one. They just feel a little, naffer than I would prefer for something that I'm selling, and I'm usually selling things. If you don't like that option, Rosewill is a vendor that makes really good, really inexpensive server-grade hardware. And you can either buy an entire rack mount 4U case with 12 hot swap bays in it for not a whole lot of money. And it's like $250, I think. Or you can buy those cases actually, they're not actually a case with 12 hot swap bays in it. They're actually a 4U server case that has 3 4-bay enclosures put right into it from the factory, and you can also just buy the enclosures, and you can put those into nearly any mid-tower case.
That's what I did for my previous home NAS. It was an old Cooler Master tower case I had, and I bought 2 of those Rosewill things that give me 4 hot swap bays each in exchange for 3 of the CD-ROM size bays in the case. So I bought 3 of those, right? And I had just all 12 drives with that kind of hot swap because it was enough for what I needed back then.
I have hundreds of those bays deployed, between my office and, various clients and whatever. The only issues I have ever had with those is specifically if you get the 4U case that already has the enclosures inserted. At least as of 3 or 4 years ago, the factory had a really bad habit of pinching a wire on the outermost enclosure, and you might have to take it apart and, fish the wire out so that it wasn't getting pinched when the enclosure got shoved all the way into the chassis, which is a pain in the butt. But on the other hand, when you're talking about the difference between a $250 case and, like an $800 case, that's not so bad, especially when the enclosure itself is very high quality and, metal, not plastic, and doesn't feel janky or weird and lasts through years of heavy-duty usage, which these do. You can also find these little enclosures that go into, and when I say an enclosure that goes into a case, for those of you who don't immediately know what I'm talking about they used to be used for optical drives, the 5.25-inch bays on the front of the mid-tower case. These usually got removable panels, and you pop those panels out, and you can stuff a giant box into 2 or 3 of those CD-ROM size slots, like it's all at once kind of a thing. So it's like you put in a triple height DVD-ROM drive, essentially. There are other vendors besides Rosewill. There's ICDoc and there's StarTech and there's several others. And most of those, again, you run into the this is distinctly cheap and cheesy factor. And I don't have enough experience with those cheaper kind of nasty feeling models to say you're gonna have a problem with those, but you might, to the degree that it's enough that I won't buy them. I've bought them to test them and disliked them enough to not deploy them in the field.
The Rosewill ones are not expensive, and so it's am I really going to save $10 to have a flimsier hot swap bay? It's either I want hot swap or I don't.
Oh, and another thing that I have got to tell you about these Rosewill hot swap bays, the trays that come out, they have holes in them for either 2.5 or 3.5-inch drives. You do not need a separate adapter.
Yes.
And if you've ever built one of these kinds of systems before and you've needed to mix and match between 2.5 and 3.5, or you bought a system with 3.5-inch trays because systems with 2.5 tend to be much more money because they're expecting it's going to go to, much better heeled organizations, well, you discover that the vast majority of the 3.5 to 2.5 adapters don't work in hot swap trays because they don't actually line up the SATA and power connectors of the drive in the right place to plug in. And the ones that do work for that almost never actually say in the product description, oh yeah, this is one of the ones that actually works in your freaking hot swap tray. So you're just left trying to buy 10 different things and guessing and hoping one of the things that you got will work and then return the rest. Or, again, you just buy a system where the trays are already dual purpose, dual fit 2.5 or 3.5, and you have no worries about that crap ever.
Right, well, we'd better get out of here then. Remember, show@2.5admins.com if you want to send in your questions or your feedback. You can find me at joyrest.com/mastodon.
You can find me at mercenarysysadmin.com.
And I'm at Alan Jude.
We'll see you next week.